Just to clarify a little bit, the end of SI, talked about saponification, and the next section is super similar. So I'm going to include that now. We'll go over it again in SI tomorrow. But the mechanism for the base-promoted hydrolysis of an amide. It's like the same thing. And in SI, I said something that wasn't entirely true, so I want to go ahead and cover that before tomorrow. So this is really going to allow us to get our nitrogen compound to be able to leave, even though it doesn't really follow our pKa rules. So it's going to be similar in saponification in that we have basically one larger molecule breaking down into two, and we also have some crazy reaction conditions, so it's going to be easy to identify it, not likely to know all of it. So KOH, that's tert butoxide. Then they included again an ether and 24 degrees. And then second step is acid workup. So HCl and water. There we go. How do I know I'm doing base promoted hydrolysis of an amide? I see all of this junk on the reaction arrow, okay? Similar to saponification, right? Before all of that, it was just two reactants. We are limited to pKa's. I know, and some of them were reversible, some of them weren't. We'll see in saponification and this base promoted hydrolysis of an amide that they begin reversible, and then when we get to our big protonation step, same as saponification, we get to that big protonation step between our two molecules. That's when our energy coordinate diagram takes a deep dive. It's also what makes this reaction go forward despite kind of going against that pKa gradient. Let's just go through the mechanism. It'll be easier. Who has electrons? Who wants them? Go. Benzene. Push those electrons up onto oxygen. I added OH, and then I had my nitrogen-containing compound. So if I did pKa's, benzene, really high, just think of them as carbons and hydrogens. Okay, not going to leave. I have OH, which is, if I protonate OH after it leaves, would be water, pKa of 14. Okay, and then if this group were to leave and I protonate it, secondary amine, it'd be like 38. Normally, if I'm just given that, this would be no reaction, right? My OH group, lowest pKa, would be the one that leaves, and I go exactly back to what I had. Hence, this is why, so far, everything is reversible. Why add all this extra stuff? It's to get our nitrogen to leave. Base promoted hydrolysis of an amide. Didn't you have to look that time? So we should realize that our leaving group is going to be the one with nitrogen here. Should get carboxylic acid and so really beginning to end, we are taking an amide and getting carboxylic acid. So saponification, we went from ketone to carboxylic acid. Oh, sorry, no, that was haloform. Sorry, that was haloform. But still, haloform, ketone to carboxylic acid. Now we can go amide to carboxylic acid. So potentially good things to know for synthesis. Let's get back to the problem. Okay, getting off track. And then I have N minus. Will a proton transfer occur between these two? Notice if it does, I get a carboxylate anion, which if protonated becomes carboxylic acid with a pKa of 4. Much better than 38. So yes, I would much rather this one have the proton than this one. This one's going to be fine as a pKa of 4. So yes, a proton transfer will occur between these two. Occur. and I'm protonating. This is when we start getting that step there and forward. This is when we get into the irreversible part. Okay, that is this part of our energy coordinate diagram. That step between this getting that proton, going from not, deciding between 14 and 38, that's major, but deciding between 4 and 38, even better. Okay, so we did that proton transfer there. Final thing we do, acid workup, and in acidic conditions, slightly different here than saponification. Both of these are going to protonate. Textbook gets lazy, so I will too. I get H+, I get a lone pair on both my oxygen and nitrogen to go over there and take that. They protonate, and I should get nitrogen with a plus charge and carboxylic acid as a final product. I wanted to clarify that before tomorrow at SI. We'll go over it again. And if that didn't make sense, rewind about a minute and listen to it again. See you all tomorrow. Hope to see you there.